Welcome to the presentation on the principles of stratigraphy. The science of stratigraphy is one of the oldest branches of geological sciences. Mineralogy is another branch which is very old. The term stratigraphy has been derived from two terms, strata or stratum in Latin and graphia in Greek, which means stratum means layer and graphia means description. Description of strata is done in stratigraphy. So, what do we study in stratigraphy? Before that, let us see who has coined the term stratigraphy. D'Orbigny in 1852 was the one who coined the term stratigraphy. For a formal definition of stratigraphy, we will see that it deals with the description of description and interpretation of stratified rocks. Description of stratified rocks means what is the thickness of the rock, what is the extent of these stratified rocks. Interpretation of the rock means what all it contains, whether it is fossiliferous, in which environment it is formed, it has been formed, what is the time in which it has formed. These have to be considered in stratigraphy. So, let us see that it studies the geometry, structure, sequence and history of rock body, studies the relationship between rock and time when it was formed, whether in a series of layers of rock, which is the oldest rock, which is the youngest rock. These aspects are studied in stratigraphy. The fossil content of stratified rocks are also studied here, but the importance here is not for the fossils, it is the time in which a rock has been formed that can be assessed, that can be interpreted with the help of the fossils that are in these stratified rocks. Initially, only sedimentary rocks were studied under stratigraphy, but later on it was found that some of the volcanic rocks are stratified and some metamorphic rocks are also stratified. Well, the entire principle, the entire branch of stratigraphy of geology is built on certain guiding principles. These principles have to be explained. In fact, we will say that initially the entire science of geology was built on this particular branch. Historical geology was considered as one major branch which had two parts, stratigraphy and paleontology. Paleontology was dealing with the study of fossils. Here you find that a number of aspects have to be discussed. Here we have to know the difference among the terms hypothesis, law and principles. What is a hypothesis? Let us define a hypothesis. As you can see, in exact sciences, experiments are performed and the various physical and chemical parameters are measured, and using this observations we give an explanation which is called a hypothesis. So, based on experiments and observations, a hypothesis is arrived at. When the hypothesis is tested, that is when the experiments are performed and observations are made a number of times, and if it is found that the hypothesis is true, then it becomes a law. The hypothesis attains the status of a law. You find that a scientific law is a description of a natural phenomenon or principle that invariably holds true under specific conditions and will occur under certain circumstances. So, a law, a scientific law becomes true, is made when we find that when experiments are performed under controlled conditions and if the results are found to be same, then it becomes a scientific law. But in the case of geology, we find that we have the experiments already performed. So, we are not conducting the experiments, we are not able to observe what is happening. What we have is the result with us. Maybe a valley is formed. This we know that the valley is formed by the action of running water from a river. So, the result is there to see, but we have not been able to see the formation of this deep seated valley. Although we know that this is true, the formation of valley has taken place because of the erosion that has taken place there. So, what is happening that the scope of observation is limited here. Therefore, the term law and principle are used interchangeably in the case of geology. So, you will find that principle of uniformitarianism, sometimes it will be called as law of uniformitarianism, law of superposition or principle of superposition, but they are one and the same as far as geology is concerned. Let us see, before going to the details of this principle, we have to find out the time in which an event has a geological event has taken place. For describing the timing of the event, when an event has taken place, we use two types of ages. These two types of ages are called relative age and absolute age. Comparison of ages of rocks or fossils or geological events using terms like older, younger, later, etc., that is called relative age. We will say that geological events are arranged in a chronological sequence using these terms. Similarly, using relative dating, but at the same time, when we arrange chronologically these events, they do not give an indication when at what time in the history of the earth this particular event has taken place. To put it very simply, in a class of say students, graduate students, a very old teacher who is standing in the class, lecturing in the class, he says that I am the oldest among the group of people sitting in this room. So, it says that this teacher was born much earlier than any of the students in that room. That is talking about relative age, whereas absolute age gives the exact number of years since an event has taken place. If the teacher says that he is 60 years old, immediately the students understand that the birth of the teacher has taken place 60 years ago. So, there is a numerical value attached to that. Here specific number of years since a rock has formed or an event has taken place, it is the actual number after the that is applied in the case of absolute age. So, remember that this sort of giving absolute age is only a very recent one, in the sense that it has taken place. Absolute dating techniques have been in use since 1905 only. Boltwood was the first one to give the absolute age of some minerals or rocks in 1905. We find that geological time scale, everybody knows what is geological time scale. This geological time scale was constructed initially using the principles of stratigraphy. What is the use of principle of stratigraphy? It means that these principles have been used in the construction of geological time scale, and from the time scale we used to say that an event has taken place, an event is older or younger than another event, a period is younger than another period and all. Only after the discovery of radioactivity, absolute ages have been given for the different units of the geological time scale. Well, there are different stratigraphic principles, a number of principles are there. I have listed the major stratigraphic principles that are very useful in the study of stratigraphy. Let me read through that. The principle of uniformitarianism, principle of superposition, principle of original horizontality, principle of lateral continuity, principle of cross cutting relationships, principle of inclusions and components, principle of fossil succession, and the last one, the principle of fossil assemblages. Some of these principles we will discuss in the first part of this presentation. The principle of uniformitarianism. Everybody in geology might have heard the name James Hutton, who is considered to be the father of modern geology. James Hutton, who lived between 1726 and 1797, gave the principle of uniformitarianism, or it is simply called uniformitarianism or the doctrine of uniformity. Here we find that it can be stated in a very simple way. The processes that shaped the earth throughout the geologic time were the same as those observable today. So, we find today that whenever there is heavy rainfall, we find that there is plenty of erosion. This eroded material is transported, let us say, through rivers, and it is deposited on the way, and it is deposited, it is carried to the sea. Deltas are formed in this manner, floodplains are formed in this manner. So, when you see a floodplain in an area, you should interpret. So, even when there is no rain, if we see a floodplain in an area, we should interpret it in such a way that this particular floodplain has been formed by have been created when there was heavy rainfall in the region. So, this is the principle of use of principle of uniformitarianism. As you can see, this is the fundamental principle that enables one to correctly interpret the past. So, that is the advantage with this principle. See, in a nutshell, this principle can be given as the present is the key to the past. Present is the key to the past. We will see that although James Hutton had given this principle, he belonged to Scotland, and he was the one who gave this principle, but unfortunately this principle was not accepted or was not popular during his time. We will find that it took a lot of time before it was finally accepted by the geological fraternity. The credit for popularizing the principle of uniformity of processes or uniformitarianism goes to Charles Lyell, who lived between 1797 and 1875, and he was the one who wrote the first textbook in geology, the principles of geology. He popularized this because Hutton was not very good in explaining his theory to his fellow geologists or fellow scientists. It took Charles Lyell, who was a zoologist who studied law and became a zoologist later, to popularize this principle of uniformitarianism. In fact, we will say that this principle of uniformitarianism totally changed the science of geology, because we find that this principle simply replaced two of the major principles of the time, which are called as the principle of the concept or the principle of catastrophism of George Cuvier, and also the principle of Neptunism of A.G. Werner. These two scientists, Cuvier and Werner, were very popular during the time of Hutton, and Hutton's theory could not replace the ideas of these two scientists. The photographs of Charles Lyell and George Cuvier are given here. We find that what is the significance of the principle of uniformitarianism? It not only is used in the study of geology, it is used in other sciences also, like archaeology, anthropology and all use this principle of uniformitarianism. And history also, historical sciences in fact use this principle of uniformitarianism. For example, when we find when we explore a forest and we come across a cave, within the cave if we find some sort of art form, some drawings on the cave walls, then we immediately come to the conclusion that once upon a time here lived some cavemen. We never presume that these figures were drawn by some animals, because we know that only now we know that only human beings are capable of drawing such sort of figures. So, using the principle of uniformitarianism, we interpret the past saying that these figures were drawn by some human beings who lived in these caves. The second principle, which is called as the principle of superposition, this was given by Nicholas Steno. Nicholas Steno, who is considered as the father of stratigraphy. He applied this this principle was first applied by Layman in 1757, although it was given in 1669. It took so many years before the principle was first applied for the stratified rocks at the Paris basin by Layman. This is a very simple principle, it is self explanatory and it is easily applied. So, what is that? Let us see. In an undisturbed sequence of sedimentary strata, any stratum is older than the one above it and younger than the one below it. To say it in a simple way, still simple way, we will say that in an undisturbed sequence of sedimentary strata, the oldest layer will be at the bottom or the bottommost and the youngest layer will be the topmost. That is the principle here. This was given by Nicholas Steno in 1669. Here we have a figure given. You can see the oldest one and the youngest one here. The bottommost layer is the oldest and the topmost layer is the youngest. So, there is one condition here, in the sense that the rock layers should have been undisturbed. If there was some disturbance, we cannot guarantee this principle, the application of this principle. It is something similar to what we have in our home. Every day we receive newspapers in our home, and after reading the newspaper, this one on a rack we put it, and after each day we put the newspaper one over the other. At the end of 1 month, we find that the topmost issue of newspaper will be the latest one and the bottommost will be the oldest one. So, here the condition is that that stack of newspaper is undisturbed. If it has been disturbed, we cannot guarantee with this principle, application of this principle. Unfortunately, undisturbed sequences of strata are rare in nature. We find that most of the strata are folded or faulted, or sometimes they are even inclined or vertical. Before applying this principle, we have to ensure that the rocks had remained undisturbed throughout after their formation. Here you have a photograph of Kadapa basin. This is a photograph published by the Geological Survey of India, Kadapa in Andhra Pradesh. Here you can see that Here the bottommost layer is here, this is the oldest and this is the youngest. So, it is very clear that this principle is easily applied for this sort of undisturbed sequence of rock layers. The third principle, which is called as the principle of original horizontality. Principle of original horizontality. Again, this was given by Nicolas Steno in 1669. See, the upper surface of sedimentary layers initially come to rest essentially parallel to the surface of deposition, parallel to the horizon. That is, whenever sedimentary layers are deposited in a basin, we find that these layers are deposited in a horizontal manner. So, in a horizontal manner, earlier we have seen the case of Kadapa basin where we have found horizontal layers there. So, originally all the sedimentary layers are deposited in a horizontal manner, that is the principle of original horizontality. Here you can see different layers of sedimentary rocks one over the other, and this is the surface, it is the planar view. Here you can see that each layer is horizontal, but below that you have a figure which shows folded layers. So, at the time of deposition they were all horizontal, but after after some time they are no longer horizontal, they have undergone some sort of deformation. Deformation means change of shape. The common deformations are folding and faulting. Here there is a fold here, these layers have been folded. Is it clear? So, the principle of horizontality states that all the rock layers initially are formed in a horizontal manner. Here again you find that some of the layers are inclined here, these layers are inclined, and this inclination we should not interpret that the rock layers were originally deposited in this inclined manner. We should interpret it as the one in which all these rock layers were initially deposited in a horizontal manner. Later on, due to some earth activity, so some deformational activity, they have been made inclined, they have been changed into inclined layers. That is what you see here. Can you see here? Here again we have this is again a photograph from Kadapa basin. Here you can see the folded layers. Can you see the folded layers here? These folded layers we should not interpret it as something original deposition was like a folded layer. This was also initially in a horizontal manner, they were deposited in a horizontal manner, but what happened was later on these layers were subjected to some deformation which resulted in the folding of the layers. Yes, principle of lateral continuity. Principle of lateral continuity says that again this was again stated by Nicolas Steno in 1669. It says that layers of sediment initially extend laterally in all directions. In other words, they are laterally continuous. Laterally continuous in the sense that when you see a layer of rock, if you trace it, actually it should extend continuously on all sides, laterally it should be continuous. But many a time we do not find such continuity of layers, the layers end somewhere. What is the reason due to what is the reason for this sort of, see, any single stratum was probably continuous, but what happened was this layer is cut by erosion at a later time or due to faulting some earth events, this layer is cut. So, when these are cut, these layers are cut, you find that the edges of these layers can be seen. Otherwise, we would never have seen the edges of layers, because they are initially deposited in a continuous manner laterally. So, if edges are seen, it means that those edges have been brought about by some disturbance or by some geological activity. Well, based on the principle of lateral continuity, we can see that originally an exposed edge of an entire layer from top to bottom cannot be seen anywhere. So, that means if you go for field work in an area, you should not be able to see the edge of a layer of rock, but many a time you will see these edges. Why it is? Because these edges of beds or layers are exposed. It is due to either breakage or breakage and dislocation, or by erosion. Let us see these things with the help of some figures. Here you can see originally this was the layer. You can see the layer being deposited in a continuous, it tapers, that is all. Here also you are not able to see the edge of the layer. But what happens after some time, you find that this is the picture that we have. Here you find that this layer, which was continuous earlier, now it is, you can see the edges here. You can see the edges at different places. This is because erosion has removed some material from here. Here also it has been removed. So, if edges of layers of rocks are seen, it is due to erosion or dislocation or some sort of deformation. Here again you can see this is these are the edges. You can see originally it was all continuous, but some erosion has removed material, and you can see the edges. This is something like this. When you are standing in a inside a canyon, on either side of the canyon you can see at the same level continuation of some rocks. It means that originally rock A, which is seen on either side of the rock, either side almost at the same level, that was continuous earlier, but now it has been, the edge has been exposed due to erosion. This is an example of such sort of lateral continuity disturbed due to erosion. This is from the Great Canyon of Colorado in the USA. As you can see that we have seen certain basic principles in stratigraphy. Now, we have come to the part 1 of the presentation of the principles of stratigraphy. We have defined the term stratigraphy and the differences among law, principle and hypothesis. Then we went on to see we listed the principles, the basic principles on which the science of stratigraphy is built. And we also defined the two terms relative age and absolute age. The major principles of stratigraphic principles, like principle of principle of uniformitarianism, principle of superposition, principle of original horizontality and principle of lateral continuity were discussed in this part of the presentation with the help of figures and photographs. We will be continuing with our presentation in the next part on the principles of stratigraphy. Thank you very much.